Hello ladies, gents, and everyones. It is Thursday, December 9th, and we're here to talk about this week's space and astronomy news. Last week, NASA announced 3 awards totaling over $415 million for the development of 3 commercial space stations. The companies that won the awards were Blue Origin, NanoRacks, and Northrop Grumman. Now, for frequent viewers of my channel, this won't be too surprising because we've discussed Blue Origin and NanoRacks and their future commercial destinations before. Blue Origin has Orbital Reef and NanoRacks has Starlab. So what about Northrop Grumman? Their aim is a 15-year free-floating commercial space station that could support a permanent crew of 4 and eventually perhaps 8 or more. Their customers would be NASA and other government or commercial entities. So far, the only partner they've announced is Dynetics, probably more to come in the future, and their station doesn't have a name yet. These 3 awards were selected from 11 proposals that were submitted back in August, and this is all part of NASA's plan to envision a post-ISS future that relies on commercial space stations. However, a NASA Inspector General report that was published last week raised concerns that these commercial space stations won't be able to be operational prior to the retirement of the ISS, leading possibly to an undesirable gap in low Earth orbit operations. So this means that the aging ISS may need to be supported into the 2030s. Some of the people who may eventually someday be using these stations might include the newest class of astronaut candidates that NASA just announced on Monday. These 10 candidates were selected from over 12,000 applicants, and they join a pool of only 360 people that have ever been selected as NASA astronaut candidates since 1959. So this is kind of a big deal for them. They're candidates for now. They begin training in January, a 2-year process that will bring them to being full astronauts. Congratulations and good luck to the new candidates. If you're watching this, you, like me, are probably waiting with high anticipation for the upcoming launch of the James Webb Space Telescope. And people, we are less than 2 weeks away. And NASA announced Monday that the telescope has completed its 10-day fueling process and it's now fully fueled and ready to go. This fuel will be used by Webb's thrusters to make tweaks to place it into its L2 orbit. More importantly, this fuel will be used to maintain that orbit, which is an unstable orbit, so it requires active orbital maintenance. Once the fuel is gone, the telescope will drift into a sun-centric orbit and no more James Webb. The mission has enough fuel for 10 years of operations, although if we get lucky and some of the maneuvers can be done very efficiently, we might get a little bit longer. This fueling was the final major task for Webb. Now it's headed to the final assembly building where it will be integrated with its Ariane 5 launch vehicle. And we continue to hold our breaths for the next 13 days and then for the 30 days after that. Speaking of launches, this morning at 1 a.m., another NASA mission was launched from Kennedy Space Center on board a Falcon 9 rocket. This was the IXPE mission, the Imaging X-ray Polarimeter Explorer, which is a joint effort with the Italian Space Agency. This mission will open a new window onto the so-called violent universe, high-energy objects like exploding stars and feeding supermassive black holes. These objects emit high-energy X-rays, and the polarization of those X-rays can tell us information about where the light originated and what it passed through on its way to being detected here. X-rays can't be observed from the ground, and while we've had X-ray observatories in space before, this is the first one that will be able to detect polarized X-rays. So it's really exciting for deepening our understanding of black holes, pulsars, and other energetic objects. The observatory carries 3 identical telescopes on board for making these observations, and the launch was successful, and we expect first light in January. Lastly, a couple cool new exoplanet discoveries. First is the planet B Centauri b. This is a really massive planet, more than 10 times the mass of Jupiter. In orbit, a round binary star, B Centauri. The planet was discovered via direct imaging and was announced this week in a paper published in Nature. The planet is orbiting over 560 AU from its host, B Centauri, making it one of the widest known exoplanets, and meaning that it couldn't have formed according to some of our most common theories of planet formation. But even stranger is B Centauri itself, a binary star with a mass between 6 and 10 solar masses. One component of which is a hot B-type star. This makes B Centauri the most massive known exoplanet host, and by a fair margin. Previous studies had found that planet occurrence decreases sharply above a certain stellar mass, usually between about 2 to 3 times the mass of the Sun. So the discovery of B Centauri b really just goes to show how much more we have to learn about exoplanets and how and where they form. When we talk about exoplanets, we spend a lot of time, understandably, talking about exo-Earths. But Earth isn't the only interesting planet in our solar system. Take, for example, Mercury. Mercury is the smallest planet in our system, and it is significantly denser than the other terrestrial planets, thanks to a very high fraction of iron. Now, while we have some good ideas, we actually do not know how Mercury came to be such an oddball. So finding exo-Mercuries could help us understand the formation of our own solar system. The challenge is that determining the density of an exoplanet requires measuring both its mass and its radius, and this is hard to do with very high precision, and it gets harder as the planets get smaller. So this exoplanet, GJ367b, which was announced last week in a paper published in Science, is really exciting. It's smaller than Earth, about 75% of Earth's radius and 55% of Earth's mass. If you do the math on what that means for the planet's density, it's really dense. It's about 8 grams per cubic centimeter, where Earth is about 5.5. This means it must have a lot of iron, just like Mercury, a true exo-Mercury. It's really exciting to be getting this kind of detailed measurements for these small exoplanets, so really cool. Well, that's all I have for you this week. Thanks so much for watching, and I will see you again next week. Have a good one. Bye!